Okay guys, so this is the whole notebook we are going to go through today, and if you would like to get the source code without copying and pasting from the video, just leave a comment with your email address or a link to your Facebook account and I will send it to you without any problems. What's up guys, it's Mike, the guy from machine learning, forex trading, the software engineer, and basically for today's video we are going to create a moving average crossover strategy and implement it into the Fxcm API using Python. So basically I will show you how the strategy was developed by me on the Jupyter notebook. I will go through cell by cell, and if you would like to do the same thing as me, just stop the video, rewrite the code to your own notebook and run the cell and move further with me. And one more thing, on the end of this video we will implement also the deep learning and see if the deep neural network can increase the performance of our moving average strategy. So let's get started. Okay guys, so obviously for the first step we need to do some imports, Fxcm, pandas, numpy, some basic ones. And also I decided to import the PyTI, so basically it's a library with the technical indicators, and I decided to import from it the whole moving average indicator as HMA. Okay, next we got of course the connection to the Fxcm server, the token fxcmpy.fxcmpy connect. Basically, if you do not know how to do this, just go back to my previous videos. I explain it deeply how you can connect to the Fxcm server. And moving next, the connection was established, so the next thing was to actually download the candles. I decided to download candles for the 1 hour period and for the last year, so basically for the whole 2019 year for the Euro USD. So basically con.getCandles, you pass all the parameters, and then I decided just to print it, so just to print the head of the data frame. So if you don't know what is head is basically the first top 5 rows. So basically this is the data frame. As you can see, we got the open, high, low, close for the bid prices, for the ask prices, and also we got the tick quantity for each candle. Next, I wanted to show it on the chart to see if it's actually a legit candlestick chart, and when I print it using the Plotly, I saw that this is in fact a legit candlestick chart. So with Plotly you can of course zoom in, zoom out, and have a better look on the whole chart rather than Matplotlib. Okay, so I got the chart, so the next step was actually to calculate the moving average. First I decided to calculate the normal moving average, the rolling mean like some people say. So basically I use 2 periods. My fast period is basically 9 candles and my slow period is the 18 candles. So basically for the moving average calculation I just use the pandas rolling method, which is calculating the rolling mean for you. So basically I pass it to the MA fast and MA slow variables, and then I printed out the tail with the parameter 5, so basically I printed out the last 5 rows of the data frame. And as you can see, we also got the OHLC for bid and ask, tick quantity, and then you can see the MA fast and MA slow values. So basically the calculation was correct. So maybe let's look it on the chart. So for that one I also use the Plotly, and then when I print it out, you can see the whole chart with 2 moving averages. And when you zoom in, you can basically see the places when the moving average is crossing. So we will use those crosses to make our strategy. So yeah, this is the chart. So next, I decided to calculate the whole moving average. Basically, the Hull was a guy who thought that the normal moving average is too slow, is lagging, and he was correct. So basically, he developed his own moving average, which is a weighted moving average, which is basically weighting the newest prices higher than the older prices. Each price has its own weight, some similar like neural networks ways. Anyway, so I imported this HMA to calculate the whole moving average, and also we got the same period, the fast 9 and the slow 18. I passed it into the pandas data frame, and if you print the tail, you can see that we also got new 2 columns called HMA fast and HMA slow. So when I print it on the chart, I can clearly see that the whole moving average is much more faster and much more precise, rather than lagging normal moving average. So the crosses of the moving average are in much more better places. So this is the chart, you can zoom in, zoom out, and the next thing was basically to compare the normal moving average with the whole moving average to see actually the differences. So I decided also to print it on the chart. So as you can see, on this one we got 4 moving averages, 2 whole moving averages and 2 normal moving averages. So you can see also the difference between both of them. You can zoom in, zoom out and play with it if you want. So basically we got this chart. The next thing was to create a strategy function that will use those crosses and make money for us, hopefully. So basically for that one I created 2 columns, the signal column and also the position column. In the signal basically I define if the fast moving average is above the slow moving average, it means that the trend is up, so it's time to buy. And if the fast moving average is below the slow moving average, it means that the trend is down and it's time to sell or do nothing. But for this strategy I decided that we will do only buys to make it easier for you to understand. So basically this is the code. If the fast is bigger than slow, just print 1, else print 0, and then in the position I just put the difference. So basically when it will be time to buy you will get the 1, and when it will be time to exit the position you will get the -1. So if you print the data frame, it looks like this. As I said before, we got 0 and 1s on the signal column, and on the position you got actually the information when to buy and when to sell. So guys, let's check it out how it look on the chart. So when I printed the chart, of course using Plotly, I can see something like this. Loads of buys and sells, and basically it tells us nothing. But if you zoom in, you can see when the moving averages were crossing each other, and then you can see the buy and sell. So basically buy indicates opening the buy position, as sell indicates the closing the position. So you can go through this chart, play with it and see how this works. You can implement your own strategies and check it on the chart using my methods. Basically this is the code responsible, so I just made a loop to print those buy and sells labels on the chart. Okay guys, so next I wanted to check if the strategy is making any money at all. So what I did, I just defined the pip cost, the lot size is 10. You can play with it if you want, also with the cost of the transaction with the pip cost variable. I made 2 loops, basically that calculates the strategy profitability for me, and then the output look is like this. The return for the period is 2046. So basically we made $2046. But yeah, let's check it out on the chart, and the chart looks like this. Really nice uptrend. So looks like the drawback it's almost invisible when you look on this chart. And of course you can play with it, you can zoom in, zoom out to check how it looked like. So by looking on this chart you can think that the strategy is making money. So yeah, let's check it out and move next. So the next thing I wanted to check was basically to evaluate the strategy and be more data, because we had only 1 year. So now I think it will be better to download the 1, 2, 3, 4, the 10 years. So basically from 2010 to 2020, the 10 years dataset. So for that purpose I made this function, download data, and you pass the asset name, and the function downloads all the data for you and merge it into one data frame. And I also made the pre-process data function method that will convert this data frame and add all of those moving averages, all of those positions, signal columns. So basically we will run the download data method, and then we'll run the pre-process data method, and we'll have our data set pretty much prepared for the evaluation. So yeah, after that I decided to run it. I ran it on the 5 assets, and as you can see we got downloaded 62,000 of hours, basically run 62,000 of hours for each asset, so it's much more bigger data set than before. So yeah, let's check how the strategy looks on the chart with more assets and more years. So it looks like this. Looks like every single asset is profitable on this chart. You can also see that the biggest performer is the GBP USD. Then we got assets like EuroUSD, USDCAD, and so on. So of course you can play with it if you want. So next I decided to make a small method that will print the state for each transaction. And what I mean by state, basically when you open a trade, you see on the chart current state. So basically you see the cross on the right side as the last candle, and on the left you usually look on the 10, 15, 100 candles back. So basically those candles that you look back are called the window when we talk about the model creation for the trading purposes. So basically I decided that the window will be 90 and made a method to print the window for each buy position we made. So when I run this method, you can see the window on the chart and also the label if the transaction was a win or loss. So let's run it on the few examples. So as you can see, some of them are wins, some of them are losses, and you can see the state. So right now, the best thing would be actually to create a deep learning model, the deep neural network, to try to learn the patterns from the entry states. So basically we will pass the entry states to our deep learning model and label them as a win or loss. So basically it's the binary classification, and we will try to teach our model to predict if the transaction is worth to open. So basically if the transaction will be profitable or not. And we will use it as some kind of filter to our strategy and see if it works at all. So basically for that purpose I had to convert my data into the NumPy arrays, as all the machine learning models operates on the NumPy arrays. Then I imported the TensorFlow with the Keras API, and I created a simple sequential model using the LSTM layer, so recurrent neural network layer, and as an activation function I use the sigmoid function for the binary classification. And also the loss function is the binary cross entropy, and optimizer mRMS prop. I use the ADAM optimizer, but I got better results with that one, so I decided to use that one. So this is the model. Then I trained this model for the 500 epochs, and when we look on the next chart, you can see how the model was learning, and looks like it's not learning as good as we wanted to learn, but something is happening. But yeah, let's check if we can do anything with this data. So next I checked the accuracy of this model by using the model.evaluate, and this is the accuracy. And then I decided to use this model to predict on the other asset. Then it was trained to see how it's working. So basically if you plot it on the chart, you can see the confidence of the model, is it worth to open the trade or not. And the red line in the middle, basically it's a mean. So what I was thinking to do is to make a filter, and every single time when the model is confident above the mean, we will open the trade, and if the model is confident less than a mean, we will not open the trade, because it will indicate that it's a possibility to lose this trade. And of course it's better to limit your losses and run your winners in the trading world. So basically this is the model. So then I decided to check if this deep learning filter is helping our crossover strategy at all. So I created two simulations, one with the normal strategy for EuroUSD and the second one for the strategy with the deep learning filter, and I plotted on the chart. So as you can see, the blue line is the normal strategy and the red line is the strategy with deep learning model implemented, and it's not helping at all. Maybe if you will play around with the input data set with different models, you will get the better results, but for now on looks like that the model decreased the number of trades, and in the same time it decreased the profitability. So it's close to a random. But anyway, it's still an experiment, and if you have an idea, just let me know in the comments how to improve this model to get better results and increase the performance of the strategy. Okay, moving next. So now we know that the normal strategy is better than the deep learning strategy, so it's time to implement it in the market. So for that one, I created a few functions, I copy-pasted from the Fxcm API library and modified it a little bit. So basically for the first one you need to import of course the libraries, then you got the token and stuff like this to connect to the Fxcm servers. Then we got the prepare method. Basically that one is downloading the data on the initialization of the trading agent. So basically it will download all the data, all the candlesticks of the window, and we decided the window will be 90. The next one, we got the strategy heartbeat. Basically when you got the new candlestick, new price update, the heartbeat function will be triggered, and then inside the heartbeat function we trigger the update function, and basically the update function is the strategy. Next we got the get last price date. So basically this function is responsible for downloading the data for us. I also created a function to open a trade, to close a trade, and this is the update function that I mentioned before. So in that one we just manipulate the data from the price data variable. We add the moving averages, we calculate the signal position, and then if the signal is 0, we do basically nothing. If the signal is -1, we close all trades that we got, and if the signal is 1, we open those trades. And then you just run the prepare, and then you just run the strategy heartbeat, and the strategy is working and is making trades for you. So yeah, that was it. I hope this video is not like half an hour. I hope this video is not so long for you and you enjoy the content. So basically that was it. If you want to get the source code, just let me know in the comments with your email address or link to your Facebook profile. I will reach out to you. And basically, if you like to get more stuff like this, or maybe you have ideas on new videos, just let me know in the comments. Subscribe to this channel and hit the like button. It will really help to grow this channel and keeps me motivated to do more stuff like this. But anyway, if you like the content, just keep in touch with me, subscribe to this channel, and basically see you soon on the next video.